Solid principles are a set of principles that can guide software developers in writing clean, maintainable, and extensible code. The S from the solid stands for Single Responsibility Principle, and it states that a class should only have one reason to change, meaning it should have only one responsibility. This process will make the code easy to read, easy to understand, and of course easy to maintain and test. And now let's move on to the example part. Let's take this simple example to understand once and for all the single responsibility principle. First of all, we'll have an employee class, and it should calculate salary and share the tasks. But why is it wrong, and why does this violate the single responsibility principle? First of all, we'll have the calculate salary method that we are gonna look about. And this is wrong to be here because every employee is different. Some of the employees might work on a daily rate, others on the hourly rate, and the implementation should not be the same for both of them. So it has more than one reason to change, at least two. And for the shared tasks, it's the same thing. For example, if we are developers, we might share our tasks through Kanban board, but if you are workers, we might share them by simply speak about what we should do next. And how would be a better approach? Let's see. So a good approach here would be to make the employee abstract, because it's pretty normal to be abstract because it's not an employee, it's an actual role. For example, the developer and workers. And if we make also both of their method abstracts, every class that extends our employee class should and would implement the actual functions. And for example, for the developers, let's say the calculate salary would be hourly rate and 5 days per week, and the shared task will be through Kanban board. But if we talk about workers, well, the calculate salary may be how many dollars do I receive in a day, and I only want to work 3 times per week, but it is independent from the developer one. And for the shared tasks, as I told previously, they maybe want to speak with each other, they don't want to have something centralized. I hope that you understand now the single responsibility principle. The O from solid stands for open-close principle, and the idea behind this principle is that existing classes should be extended but not modified. By modifying existing classes, you may risk breaking code which was already tested and reviewed. Now let's see a violation of the open-close principle. So we'll have a class that is called shipping, where we'll have some shipping option cost and a method that is called getShippingCost. And we want to see if the shipping cost is a car, we will return 50, and if the shipping cost is a plane, we will return 100. That is going to be how much it costs to ship some object through car or to plane. But let's see what happens if we want to ship it through, let's say, a ship. So if this shipping option cost will be equal with ship, then we will return, let's say, 300. But right now our open-close principle is violated because our class is now modified but is not opened to extension. So what would be a better approach? If we comment this and switch to the other file, we will see a better approach. So we'll have the same shipping class, but right now we'll have an interface that is going to be called costs that will have a getCosts method in it. And we'll have 3 different classes, that is car cost, plane cost, and ship cost, and all of them will implement the cost, and with that we must declare the getCost function, and each of the classes will return their proper value. And right now in our shipping class, we will have shipping option costs to be of type costs, and our getShippingCost will simply return the getCost of the shipping option cost. And with this approach, I hope that you understand the open-close principle. The Liskov substitution principle presents the following thing. When extending the class, remember that you should only be able to pass objects of the subclass in place of objects of the parent class, without breaking the client code. And let's see a violation of this example. Let's say we have a rectangle. We have the width, we have the length, we could set both of them and calculate the area. And let's say we have a special rectangle that is called square. Well, we both know that when we want to set the width and set the length of a square, well, we must set both of them since the width and the length are the same value. And the problem here comes when we want to, for example, initiate a rectangle actually, but we say that it's a new square and we set the width to 20. Well, right now when you want to set the width to 20, both of the length and the width will become 20, and maybe we don't expect this. Maybe we want to just set the width to 20 because we say that we have a rectangle. But we can of course use this type of if rectangle instance of square, else if rectangle instance of rectangle. But it's not nice, and of course it violates the Liskov substitution principle. But let's see how can we resolve this. So I have this good example right now where we extract the get area in an interface that is called shape, and both of the classes, the square and the rectangle, we want to say that they're a shape. And of course we can set the width and set the height and get the area, but right now the actual square will not set the width and the height separately. He will set the side this time, and he will have his only get area method. Of course also the rectangle will have its get area method, and right now the principle is not violated anymore because we cannot do something like we can create a rectangle and say it's a square. And right now you understand what the Liskov principle is. Interface segregation principle stands the next way. Clients shouldn't be forced to depend on methods they do not use. And the idea behind this principle is that it is better to have smaller and more specific interfaces rather than big ones. So let's take this example into consideration. Let's say we have three different classes that will represent our clients: the future car, the car, and the airplane. And all three of them will implement this vehicle interface that is going to have the drive and fly, which is not actually pretty normal because our interface is pretty big and not all these vehicles can also fly and drive. Let's say our future car will drive and will fly, but for example the car cannot fly yet and the airplane cannot be driven yet. But how can we actually implement it with a better solution? So to have a good implementation of the interface segregation, we should of course have a car interface and an airplane interface. And we will say something like that the future car will be both a car and an airplane because he can fly and be driven. A normal car will be just a car that can be driven, and an airplane will be just an airplane interface because it could be flying. And that was all. I hope you understand now the interface segregation principle. This dependency inversion principle is a design principle that states that high-level modules should depend on abstract rather than concrete implementation, and this will help us to decouple the high-level and low-level modules, make it easier to change the low-level ones without affecting the high-level ones. Now let's take this example into consideration. We will have a CRUD service that will take a MySQL database that is defined below. We can insert an update, and we want to say something that we have a save function, and if the object doesn't exist we should insert the object, else we should update. Well, this is a good construction, but it skips a very important thing. What will happen if, for example, we want to have two types of databases in our system? And for example, let's say my Mongo database. Right now, as our CRUD server is dependent on MySQL database, we could not use it. And how can we solve it in a good way, the dependency inversion? Well, we could actually extract as an interface the database with the save option and pass the responsibility to save to every database, to my SQL database and to my Mongo database. And the save functionality where we insert or update should be directly in that specific class. And in our service, we could simply use the generic database and when we want to save, we should call the save function from that specific database. I hope that now you understand the dependency inversion.